My screen is visible, right? So we were seeing the Xarray official tutorial last time, and let us go back to where we left. So we saw how to install Xarray, and then we were running this notebook in a live session, in a binder session. And so did anybody of you go back and try this notebook? Do you have any questions? Yes, no. I'm audible. Hello.
Yes, sir. Yes, sir.
Okay, fine. Okay, until the time this is loading, let us start with the next notebook. So working with label data, and how you would basically select different date time and interpolate to new coordinates. Let us see if this is starting. Hmm, Okay, so we saw this notebook last time. Data structures from multidimensional data, and we ended at how you would. So we discussed about data arrays, data sets, and we discussed about how you would create a data array. So the syntax is, so you would first have to import Xarray as XR, and then the syntax is, so you would say XR dot data array, and then the first argument that you would give is, let's say, maybe a numpy array, and then the dimensions and the name of the data array, and then you would give the coordinates. So coordinates are mostly similar to the dimensions, but they also have the values rather than just having the names. And then you can have the attributes of the data array. We did not see the attributes for the dimension or the coordinates. We'll see that. And then, yeah, we saw how to create a data set. So data set can consist of a number of data arrays, and this is the syntax for creating a data set. So you'd have to say, you have to make a dictionary, you have to say data bars equal to, so the name of the variable, so just a data charge. Okay, so yeah, charging. Okay. Yeah, so then you can transform from a data set to a pandas series. You can also transform to a pandas data frame. And today we will see this second tutorial notebook, which is working with labeled datasets. So, so it says that labeled dimensions really help to make the code less difficult to understand. Consider compare pure NumPy indexing. So let us run this. For this is just for importing the libraries. You set the random seed to a fixed number so that the results are reproducible, and then we create a 2D array of size 3 by 4, which is and the numbers would be random. This array is created from a random number generator. So you can see if you access a particular element of that 1 comma 3, so that number is minus 0.15, and then you can even slice that numpy array. These things you must have seen in the basic Python course. I guess NumPy has been taught, right? Hello. Has NumPy been taught to you guys?
For MRP, no, sir.
No. And what about IITM JRS?
No, sir, we haven't taught.
Oh, okay. So actually, you guys could have told me, like I would have covered NumPy first. And anyways, so I guess some of you have experience in NumPy. I will cover it in the next class. So okay, so NumPy is basically it's like for standard mathematical operations that you would do using Python, but NumPy functions are optimized and they would run faster than what you would typically write. So you can see that. Okay, so to basically you know that, right? The indexing in Python starts from 0.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So you can see that so this is colon 2, so this will be 0 and 1, and this is 1 colon, so this was having dimension 4, so this will be 1, 2 and 3, so because 0, 1, 2, 3 are the indices, so this will be this creates a 2D matrix of size 2 by 3, and then you can just make a Xarray data array out of this NumPy array, and then you can just define the dimensions. You can set them equal to you can give a tuple here. So we'll discuss. Okay, I didn't know that you guys don't know about NumPy as well. So NumPy has got different or like okay, this I think you must have been taught, right? So tuples and lists are in Python data structures. So this is a tuple, and then if you can just you can just say ARR. So this is the Xarray data array dot ICell. So if a NumPy was not taught, was pandas also not taught to you? Was pandas taught?
No,
No, sir.
sir.
No,
Okay,
sir.
okay.
No, sir.
So okay, we'll see pandas as well then. Okay, so so if you want to select the so what you are doing here, okay, so you were just indexing the NumPy array. So you are saying square bracket 1 comma 3. You can just say arr dot icell x equal to 1 and y equal to 3. So that basically gives you the same number. Now we'll see why and how this is useful. So you can also pass a dictionary with a key value pairs. So you can say x colon 1 comma y colon 1. So this will return you 1 comma 1, which is minus 0.977, and which is this number. So then you can create a data set. Okay, so you can, this is similar to what we saw in the last class, but you see here we create a data set with two data arrays A and B. Now A and B have got two dimensions, X and Y, and these are the values of the data array A, and this is the value of the data array B. And now if you want to select something from this data set. So you can say ds.icell x equal to slice none comma 2. So basically you can say slice none comma 2 or 0 comma 2, and then you say y equal to slice 1 comma none. So this will be similar to what you are doing here, colon 2 and 1 colon. So you see what we get here. So you can see that we have sliced successfully over both the data arrays which are present in this data set. So rather than doing it separately over these data arrays, we have sliced in one go. We have sliced over the entire data set. So you can slice over the dimensions. This is very useful when you want to slice along the latitudes and longitudes. And you can also say ds dot head uh, x equal to 2, y equal to 3, and so right now you can just see all these values, but for large data sets, all you cannot just, you can click here, but like you won't be able to see all the values because there's so many numbers. So this will just give you a sneak peek view of the data. And then the coordinate labels and label based indexing. Okay, so you can also add coordinate labels. So you see here coordinates, we are adding the coordinates, these are the values. And then this is a time coordinate, so this is starting from 2009 0105, and then we have 6 numbers here, 6 periods, frequency is monthly. So we'll see what this is. So you see here we have this random number generator is generating a 4 by 6 matrix. So this is that 4 by 6 matrix. There are 2 dimensions x and y. You're getting these 2 dimensions x and y, and then you're getting the 2 coordinates x and y. So the first coordinate is x is having some values, you can see these, and the second coordinate is y. So you are having values in this data set corresponding to every x and every y. Now, if you want to select the data by coordinate labels instead of integer indices, so here, if you see previously what we were doing was we were selecting based on the indices, because we were knowing the dimension names, but we were not with our dimensions or the coordinate. We did not have any coordinates. Dimensions did not have any values. So here you can select based on the coordinate value. So you can, rather than icell, you would say arr dot cell. So you want to see what is the value of the data. Okay, this is a data array, value of a data array at x equal to 5.3 and y equal to this date, 30th of April 2009. So you can see we have 30th of April 2009, and what was the value at x equal to 3. So you see the value is 0.38. Now sometimes what might happen is that so if you, let's say, sorry about that. So your numbers x is, or this can be a latitude or longitude. So this has 4 numbers, right? The dimension is the size is 4, minus 3.2, 2.1, 5.3 and 6.5. If you want to know something, let's say at x equal to 4, now x equal to 4 you can see doesn't exist there. Where is that? So x equal to 4 doesn't exist in this number, but it lies somewhere in between 2.1 and 5.3. So I mean, traditionally it would be, you would have to write some amount of code, but Xarray has this facility wherein, and let us see if we have the 1st of April here. So you see this as 31st of January, 28th of February, 31st of March, 30th of April, 31st of May. So we don't even have the 1st of April. Now what this would do is so you have this argument known as method. So this will select the nearest value to x equal to 4 comma y equal to 1st April, and it will return you this number. So the nearest value for x equal to 4 is 5.3. The nearest to 1st April is 31st of March. So you can see that Xarray has automatically selected or given you the data for the grid point which you are asking, which is not even there in the which is not there even there in the coordinates. Now you can also select multiple values. So you can say ARR dot cell x equal to, so you say you want the values at -3.2 and 6.5, and if you want continuous values from a particular number or date to a particular number or date, so you use this function slice. So you say y equal to slice, and then you would give, so y is a time, so you would say 20 from 28th of April to 31st of May. So let us see what we get. So you see we have got x equal to -3.2, 6.5. Drop the data based on a particular condition. So you can say that if you want to drop all the values in the data array corresponding to x equal to -3.2 and y is equal to 5.3. So you can see that can't see right until now because it's taking some time. I don't know why is it slow. Oh, is my screen visible?
Yes, sir.
Yes,
Hello?
sir.
Yes, sir.
Is my screen visible?
Yes, sir. Yes, sir.
Yes, sir. Hmm?
Hello? Is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
But it's not moving. Okay. Okay. Yeah. There is some network issue. Okay. Okay. Network issue is there. I will connect to a different network. Okay. Hmm. You can see my screen, right?
Yes, sir.
Yes, sir.
So okay. So we were running this one, and you can see that this, if you drop this two coordinate values -3.2 and 5.3, so now you can see that x only has 2.6, 2.1 and 6.5. So 3.2 and 5.3 have been dropped, and now your data array is of the size 2,6. So now we will see some real examples. And Xarray has got this data set air underscore temperature, which is for like just for demonstration purposes. So this one, now we print this data set ds. So this one has got lat of size 25, lon of size 53, and we have the time 2920. So you can see the latitudes are ranging from 75 to 15. So you can see that they are ranging from a higher number to a lower number. And then you can see we have the longitudes, which are named as lon, so which is from 200 to 330. And then we have the time, so which is from 1st of January 2013 to 31st of December 2014. The name of the, so this is a data set having just one variable or one data array, which is the name of the variable is air, and this air has got three dimensions: time, comma lat, comma lon, and these are the attributes. So this data is from, okay, 4 times daily NMC reanalysis. So what are the descriptions of this data? Now it says select the first 30 entries of latitude and 20th to 40th entries of longitude. Okay, so now you are not given, you don't know the exact latitude to select, so you would select based on the indices. So you would say ds dot isel. Okay, so you would say, so it says select the first 30 entries of latitude. So you would say lat equal to slice 0 comma 30, and you would say dot isel lon equal to slice 20 comma 40. So let us say what this gives us. Okay, so this gives us so latitude of size 25, longitude of size 20. Okay, so yeah, this had a latitude of size 25 only. So 0 to 30 would basically mean you're selecting all the latitudes. Longitude has size 53. So you're just selecting from 20 to 40. So you have to see, the important thing here is we are using ICEL because you are selecting from the indices. So you are selecting from what are the from the index coordinates, like coordinate, selecting the coordinates from the indices. And now it says select all the data at 75-degree north between January 1, 2013 and October 15, 2013. So you would say ds dot. So now you have the actual number, right? So you are given this actual number, which is 75-degree north. So the latitude you are given is 75. So you have to select, you have to use cell. Now you won't use an I cell here. So you would say lat equal to 75, and then you have to select the time between this time. Okay, so we will say cell time equal to, so we have to select all the times between this range. So we would use slice. So we would say, so first we will see what is the format in which the time variable is. So we would just copy this format. So they are saying between 1st January 2013. No, this is 1st January 2013 and October 15th, 2013. So we would say 10 and then October 15th. So you see, there is an error here because we did not use a colon, not a colon, a sec. Okay, so you can see we selected the data corresponding to this latitude 7, which is 75-degree north, and we select. So we don't give a criterion for longitude. So it selects all the longitudes and the time. So the time is from, so you can see from 1st January 2013 to 15th of October 2013. Now it says remove all the entries at 260 and 760 degrees. So you will say ds dot drop cell. Okay, and so 260 degrees, this seems like longitude. Okay, so you would say lon equal to, so you see how the syntax was when we have to remove the values. So that is, so you would say lon equal to 260, 270. Okay. Okay, what was syntax? So we are saying ds dot drop lon. Are we having the lons from 260 to 70?
Yes, a comma is missing, sir. 260, comma 270.
Hmm. But they are not giving any. Oh yeah, comma. Sorry. Yeah, thanks for that. Yeah, that's what I was thinking. Comma should be there. Okay, yeah. So you can see we have dropped this two lawns, 260 and 270, and we don't have these two lawns now. So it so 257.5 directly goes to 262.5, and then we don't even have the 270 ln equal to 270. Now Xarray also gives you a, so you can even do interpolation. We would skip this because there is a separate library for this. It's known as XASMF. So we would do interpolation using that, but okay, we can see what they're saying. If you want to look at values between the current grids, we can do that with interp. Okay, so you say arr dot interp x equal to this one, y equal to, okay. So let us try this. So if you remember, our ARR was a monthly data set. So now they are trying to make it into daily, and for these x's which were not there in the data. And while trying to extrapolate, the resulting values will be none. If we already have an object with the desired coordinates, we can use interp like. So you can see, so you see, okay, so basically you have this data array other, and now you want to interpolate this array arr to the coordinates of this. So this is very handy because a lot of times you would have to interpolate uh, from and to different grids. So you can just directly say interp like and says other, and then so it says increase the step size along latitude and longitude from 2.5 degrees to 1 degree. So let us see what is there in our data. So we have ds, so you can see the step size is 2.5 in latitude and in longitude. So now to interpolate, so you would use this syntax. You will copy this from here and see how to do the interpolation. So you would just say dot inter, and you would say lat equal to np dot arrange. It says from 2.5 to 1. So np dot arrange 75 to, which is the last one, 15. First let us check whether this runs or not. So np dot arrange 75 comma 15 doesn't run, so you have to give -1. Okay, so you would say up to 14. Okay, so you give this latitude. So we are also giving the step size to np dot arrange, and then we have to give the longitude. Longitude is from 200 to 330. So 200 to 330. Now this step size is positive. So I think we are pretty much done. Now if you see this, what this will give us. Hmm. I think it's taking some time because maybe they don't have that much RAM. I am audible, right? There is no
Yes, sir.
technical issue.
Yes, sir.
Okay,
No, you
fine.
are audible.
Yes, sir. Yes, sir.
Okay, thanks. Huh. So you can see that okay, now we have all the latitudes from which are having a step size of 1. Longitudes also have a step size of 1. Okay, so the size of this has also increased. So previously our so if you see we have not saved that to anything. So previously our number of lats was 25, lon was 53. Now it is lat is 61, lon is 130, and we are going from 200 to 329. So I think we should have given 331 because it doesn't consider the last number. Then p dot arrange, and then you can also do something which is broadcasting and automatic alignment. So okay, so you see you have these two data arrays A and B. Now A and B have the same dimensions, everything is same. So you can just do A. Xarray will automatically take care of all the dimensions and stuff. Okay, or it will arrange them based on what, like how it should do that. Okay, yeah, I mean this is not something, I mean, which is very commonly used. So you would mostly work with latitude and longitude data, or uh, I mean, if some MRFE fellows are working with some NetCDF datasets, so mostly they will be graded datasets. So then we would go to this next example, which is computation with Xarray, and you would see different use of different functions: mean, sum, apply, ufunc. It's a very important function with which you can broadcast or use the parallel computing capabilities of Xarray. We would see group by, resample, rolling, and Coarsen. So first, let us import the libraries. Okay. Then we have to load our data set. So they are saying so the data set that they use is NOAA extended reconstructed SST v5 product. And since the data is provided in open app server, we can load it directly without downloading anything. So would load the data set. Hmm. Okay, so the data set is loaded. This data set is looks like a global data set with the latitude from 88 to minus 88, longitude from 0 to 358, and we have the time from 1960 to 2018. It looks like a monthly data set. Yeah, it's a monthly data set. The variable name is SST. So you can see these are the SST. I think these are the SST anomalies from SST version 5. Now, very good feature of Xarray that you should know is, so you see we have this DS, which is the data set. So to access the variable, so you would say ds.sst. Now what you can do is, so we can access the first so if you see the shape, if you see the dot, if you say dot shape, it has a shape of 708, 89, and 180. So the first dimension or the first coordinate is time. So you can either say ICEL time equal to 0. So ICEL this one, or you can say this one, or you can say time equal to you can say the first of January 1960. we'll put it in the. So these three syntax, they mean the same thing. We'll comment this for now. One very good feature of Xarray is that you would have to visualize that. So we would see what the first one is. So you can see that this is a two-dimensional array, data array, and which has got this information about coordinates, time. So you can just say dot plot, and you see Xarray will plot the spatial map for you. So since this is a 2D data, Xarray understood on its own that it has to plot the spatial map, and these things it has picked up from the. So you see the latitude has got the attribute, long name is latitude, and the attribute of the long name attribute of longitude is longitude. We have the units. So all these things, units, the long names, the name of the variable. So you see where is our SST? Okay, so SST, the the long name is monthly means of sea surface temperature. So you can see monthly mean of sea surface temperature, and then the units, and then for corresponding to what time it is plotting. So that time you can see is here. Okay. So since you passed a 2D dataset, Xarray understood on its own, and you can give something like matplotlib. You can give vmin and vmax. So this the color bar ranges from -2 to 30. Now, if you would have given it something like this, okay. Now what it will do? It will plot a histogram. See, Xarray doesn't know. So this is a data set which is time cross latitude cross longitude. Xarray. So what you give is a 3D data. Now it doesn't know what to do. So for 3D data, it just plots the histogram. If you give a 2D data, it will plot a line diagram. If you give a 2D data, it will plot a spatial map. Okay. So yeah, we have to say the first one. So then in Xarray you can also, so this was in Celsius. You can convert it to Kelvin. So you can just say ds SST plus 273.15. Now this is SST in sea surface temperature in Kelvin, and it says the dimensions and coordinates were preserved during the operation. So the coordinates, so these they don't change. Although many Xarray data sets have a units attribute which is used in plotting, Xarray doesn't inherently understand units. However, work is underway. Okay, so they are using Pint, which would provide full unit aware operation. So if you are adding 273.15, so Xarray should be able to understand. They are saying that you are going from Celsius to Kelvin, and in the attributes, oh, where are the attributes? In the actually in this attributes, the units were degree Celsius. So if you add to 73.15, it should automatically transform the units to degree Kelvin. And you can do various operations directly to the to you can apply this kind of complex functions. And it says, imagine if you want to compute the following expression as a function of SST in Kelvin. So you would say zero point 0.5 into log of theta square. So you can just directly see this. You can just directly use any kind of mathematical operation on an Xarray data array. However, if you do that on data set, this will throw up an error. So you can see this your it does directly, this function was applied to your Xarray data array. And now also, so another thing is, so this thing is a very important. So if you just put a question mark in front of any Xarray data array, okay, so let us see what this was. So this is actually a Python capability of Python feature. If you put a question mark, it will tell you show you all the documentation about that particular function. Or you see, if I say, for example, if I say print question mark, so you see if you don't even need to search on Google what that particular method does, or if something is a keyword in Python, you can just put a question mark and then it will print you what it does. You can even say if object if not found, okay, or it doesn't work for that. Okay, fine. So there is this function T90 from T68, and it says it's awesome. We can apply a log of ds, just work. However, not all third-party libraries work. In this example, we'll use functions from Gibbs seawater toolkit package for the thermodynamics of seawater, and this package provides u functions that operate on numpy arrays. So if you want to op- if you want to use this function T90 from T68, so you can see that this has you can just apply it directly to this Xarray data array, and it has returned you the function. And it would be nice to keep all our dimensions and coordinates. We can accomplish this with xr dot apply ufunc. So we will see apply ufunc. So you see, I mean, I think this was maybe in the older version of Xarray that this must be returning a numpy array, but now you can see it is directly returning an Xarray data array. But if you have a function, so which operates on numpy arrays, so you can just say, and you can just pass your Xarray data array as a second argument, the name of the function as a first argument, and you can just say apply ufunc. And you can see for now this does the same thing. I think they have incorporated this in the this latest version of Xarray. So another thing that you can do is, so a lot of times you would need to find out the climatology or the mean along different dimensions. So let's say you extract the SST and you said SST equal to ds dot SST, and you want to find out the mean along the time. So you would say SST dot mean axis equal to 0. So here the axis is axis equal to 0 is time. You can also say SST dot mean dim equal to time. Okay, that would mean the same thing. So this has also resulted in the same climatology. So you get just a data array of a two-dimensional data array in latitude by longitude. And if you want to see the mean across the first and the second dimension, so this is area averaged mean. You just have the time dimension left, your latitude and longitude is gone. So these are those numbers. And if you want to calculate the absolute mean of SST across all the dimensions, so you would just say dot mean. And however, rather than performing reductions on axis, we can perform them on dimensions. So like I was saying, you can say SST dot mean dim equal to time. And now they have this exercise. So take the mean of SST both in latitude and longitude. So you would say SST dot mean dim equal to lat dot mean dim equal to lon. Okay, so we'll see if this works. This works. Now you would just say dot plot. You don't need to give anything. Xarray has all the information of time, you see, and this is a one-dimensional data set. So it should basically plot a time series on its own. You see it has plotted a very nice looking time series. And you can do different things on this, so that we will see those things. So you can use all the capabilities of matplotlib. You can change the font size, labels, xtick labels, you can put grids here, so you can do all sorts of stuff. And then another concept is of broadcasting. So broadcasting refers to the alignment of arrays with different number of dimensions. So NumPy's broadcasting rules based on array shape can sometimes be difficult to understand and remember. Xarray does broadcasting by dimension name rather than array shape. So broadcasting is basically, if you, I mean, you are not doing the computation element by element and then broadcasting, like doing computation on vectors. So this basically is efficient, computationally efficient and fast. And now he says that okay, let's create two arrays with some dimensions in common. For example, this will create a weights array proportional to the cosine of latitude modulo a normalization. This is the correct area weighting factor for data on a regular lat long grid. So you say np dot cos of so you convert the latitude from degrees to radian and then compute the cosine of that. So that becomes this weights, and then the dimension of this weights is just lat. So you can, if you multiply this by SST, just works fine, and the arrays are broadcasted properly. So the thing is, so you see, if you now multiply this weights with SST, so SST has time, comma lat, comma lon. So what you would typically want is that along so this the values of the weights along a particular latitude, it should get multiplied to all the times and all the lons. Okay, so Xarray would automatically understand this kind of broadcasting, and you can another thing is weighted reduction. So we could imagine computing the weighted spatial mean of SST manually like this. So if you would want to do it manually, you would have to, okay, so this is SST, so you would come, so this becomes a weighted SST, like with some cosine of latitude multiplied to SST, and you would say dot sum, you would sum in the dimension like lat and lon and divide by the sum of all the weights along the time latitude dimension. And if you plot this, so it says, yeah, this is wrong because the denominator needs to be expanded to include the long dimension and modified to account for some missing values, which are the land points. And in general, weighted reductions on multidimensional arrays are complicated. To make it a bit easier, Xarray provides a mechanism for weighted reductions. It does this by creating a special intermediate data array weighted object to which different reduction operations can be applied. So let us see that. Now you can see this SST weighted. So you can say ds.sst.weighted. So if you want to weight the SSTs by using these weights, so you would just say dot weighted, and it says data array weighted with weights along the dimension latitude, and SST weighted dot mean if you want to plot the mean along like global, like you want to take the mean SST along longitude and latitude. Now this is the correct global mean SST, because so why that was not correct, so was because it would also account for the previously it would account for the land points. So you would see where the values are going in this one, and you see here we are getting correct global mean SST values. Okay, so then you can also use the various functionalities of pandas. So pandas has got this function group by. So it they have basically directly taken everything from pandas. So for example, let's examine the time series of SST at a single point. Okay, let us do that. So for the point ln equal to 300, lat equal to 500, we plotting the SST. And as seen from the plot, the time series is totally dominated by seasonal cycle. We would like to remove this seasonal cycle called climatology in order to better see the long-term variations in temperature, and we can accomplish this by using group by. So you can see ds.time. So what is ds.time? So this is all the time from 1st January 1960 to 1st of December 2018. And so what does group by basically do? So it returns a group by object for performing grouped operations. This will be more clear once you actually see this group by function. So you can also so from the time dimension, so you can also extract, you can say, so it's a date time, it's of data type date time. So you can say dot dt dot month. So this will just this will just give you this months. So from 1 to 12, and then you can say group by. So ds dot group by. So you can just give this ds dot time dot dt dot month, and now you see it has been grouped over month. So 12 groups with labels 1 to 12. And Xarray also offers a more concise syntax, so you can just directly say time dot month. This will also do the same thing. Now this after you have done this, so you can also print the different. Okay, so you can print the different group names. You can see in this what is group ds. Where was our group ds? Okay, so from it is taking from this group by this object, and so the first this data set is group ds. So you can see it has printed the times. So you can see that we have all the Januaries here. Okay. So because this was for group name comma group ds in GB, and we did a break here, so this ran only once. So the value of group ds will be corresponding to January, and the group name is 1. So now you can do different things on this after doing a group by. So the first thing is that you can do is, so okay, so then there is another method of Xarray. So that is the dot map function. So dot map, what it does is you have to give a function and the arguments that the function takes. So it would apply the function to these arguments, and it would return you if the whatever the function is returning. So let's say we say define time mean a. So time mean function basically takes an argument a, and it returns a mean along the dimension time, and you would want to apply this to the this GB group by data structure. So you see this. So now we have applied the mean along the time to this group by. So this had all the data grouped along the months. So you see now we have just a new dimension, or a new coordinate month, and a new dimension month having value 12. So we have basically created a monthly climatology, and so they say that gb dot mean dim equal to time. This does the same thing. So this would remove time, and this would just create this dimension month. And now if you plot this climatology, so you see that you can see this climatology at this longitude and latitude. And now so you can, okay, so you can also see the on the x-axis is the month, on the y-axis is your latitude. So you can see your zonal mean climatology, and the difference between, okay, so you can do a difference between July and so you can say January minus July climatology. So you can say ds dot underscore mm dot sst dot cell month equal to 1 minus month equal to 7 dot plot. If you say dot plot, it would just directly plot these things for you. And we would also want to remove the time mean. So we would want to plot the anomaly. So instead of time mean, now you say x minus x dot mean, and then you map, you apply this to this group by object. So then if you see, this is your anomaly data array, and so Xarray, it says, does these things very easily. So you can just say group by time dot month, group by minus, so GB minus GB dot mean dim equal to time. So you get this DS anomaly. And then now if you plot the time series of that single point, so this time the time series that you were getting something like this, which is said they were saying was dominated by seasonal cycle. So seasonal cycle basically means that you have the January to December seasonal cycle dominating the time series. So that time series now you get is something like this after removing the seasonal cycle from the time series. Okay, and then you can also so resample. You can also use this thing known as this function known as resample. So resample, what it will do is, so if you have ds underscore anomaly dot resample time equal to 5, so this will resample your data based on, it will basically group it in the so it has grouped like what 30 years or 40 years of data into 13 groups. So 5 years, so 5 years it will group into a single or aggregate all like 5 years. And then you can see that so resample object dot mean dim equal to time. So if you take a mean along the time dimension, so you can see that now you have data for 1960, 1965, 1970, 1975. So you basically resampled, so you basically aggregated the data for every 5 years, and then you took a mean along time. Okay, so you basically get mean of the values for like 5 year mean. And then if you want to plot this resampled 5 year resampled time series for that same latitude and longitude, so you can see this, it is the using marker equal to o, which is similar to matplotlib. And you can also use a rolling function which is similar to pandas. So basically moving average, something like a moving average. So you can say ds underscore enorm dot rolling time equal to 12. So it will take like every 12 months, so a rolling mean along the 12 months. And then you can calculate the rolling anomaly. So and then you can plot it at that same latitude and longitude. I think I am beyond my time. And has the next faculty come? Hello.
Sir, please mark my attendance.
Okay, who's this?
Soma Misra.
Okay, yeah, I'll mark your attendance. But has the next faculty come?
Sir, mine also, sir.
Sir,
Hello, sir.
my attendance.
Yeah, just wait. I will mark the attendance. But what is your next class?
There is no class, I think, for the JRF. But
MRFP also there is no class.
Okay. Okay, fine. So I will just take the attendance and then we will meet again at 2 o'clock.
Sir, have you marked?
Just, yeah, you are Soma, right?
Yeah.
Yeah, Soma, I'll mark for you. Yeah.
Sir,
Okay.
this is Soma Burman.
Okay, just a second. I will take attendance for everybody. First, let me stop the recording.